holiday day, in case you wondered. Oh, I have a Christmas tree. So, getting a lot of comments like, nice time. All right, so many of these questions you're going to be drawing from what you learned from the pre-quiz video. So if you didn't do that, well, it could be a little bit rough. Tell your neighbor.
Wait. I don't know why I said that. I'm stupid.
Correct answer is? Correct answer is E. Okay. Squaring that. Okay. Here's what intensity is communicating. Is how much energy goes by a certain area every second. Okay, so it looks kind of like at the flow of energy through an area. Here's my analogy. Let's say you have a jar of jelly, pull out a spoonful of it, okay, and you just eat it straight out. That's like you being at the source of sound. Okay, the jelly represents a certain amount of energy. Okay, so let's say we take some steps away from the source. That's like taking the same spoonful of jelly and spreading it over a saltine cracker. It's like, would you like some cracker with your jelly? Thank you. Then we take some more steps away. We take that same spoonful of jelly and we spread it over a piece of bread. The same amount of energy, just over a bigger area. Okay, and that's like, that's good. We take some more steps away. We take that same spoonful of jelly and we spread it over a pizza crust. Okay? At some point, it's like, I get a little hint of jelly, but it's like, it's the same amount of area. We're just spreading over a greater and greater, same amount of energy. We're just spreading over a greater and greater area. Okay? If you throw a rock in a pond, the waves, the ripples go out in concentric circles. A sound wave coming out from a source of sound is like a bubble. Okay, that goes out at 343 meters a second. That energy is spread out over the surface of that area, of that sphere. So it's getting diluted, getting spread thin. That's why it's hard to hear if you're far away from somebody. There's still energy there, it's just getting spread out thinner and thinner, just like jelly on a pizza crust. You okay with that? Okay. Talk to your neighbor. Correct answer is? Correct answer is C. Okay, intensity is, we like intensity in physics. It's a linear scale. You got 400s, one of them. Two of them would be 800. Three of them would be 1200. They just add up. They're summative. It's like if they all have the same intensity, you just multiply the number of sources by the intensity of one. Are we okay with that? Okay. Tell your neighbor.
I forgot. I was thinking first, I like how I usually do. I'm like, there was a pre-quiz. Or I do it after 7:30. I can't. I do many ways. Just to get the information.
Correct answer is C. Crazy cats. Okay. So here's where things fall apart. Like this, like, yeah, 3 times 400. Easy, got it. When we start mixing it in with our perceptions, like, oh, that's twice as loud. When we go to measure the intensity, we find that it's actually 10 times the intensity. We're like, oh, I wish I could say we were wired differently, but we're not. This is just how we do that. Okay. Tell your neighbor. Assuming that each guitar player has the same intensity, correct answer would be C.
Yes.
Okay. Yep. I know. Okay. So if we hear something that is twice as loud, we're multiplying our intensity by 10. It's 10 times the intensity. In order to produce that, because each time each source contributes a certain amount. Okay. The total intensity for this one, our first question, was 1200. Okay? In order to get 10 times the intensity, we need 10 sources, 10 times the number of sources. Okay? We have a perceived volume. Okay? If we have one guitar player, in order to have a perceived volume of twice as loud, like, whoa, that's twice as loud, that requires 10 times the number of sources. It's just how our brain is wired. Tell your neighbor. What are we thinking? Dented doorknobs. Okay? 10 times the amount. Okay? Proof of concept. I want everybody to look up on YouTube 1,000 hertz sound. You already have your phones out, most of you. Go to YouTube.
Start playing.
No, don't play it yet.
Wait, what do we do? Search up 1,000 hertz. What? Okay.
Okay, go to 10 hours. It's a black screen.
Mine is not a black screen. Pure sine wave.
Just how we're wired.
It's this one. I can't find it.
Do you want our volume all the way up?
Crank your volume all the way up. Okay? Don't play. I mean, go ahead and just get it queued up, ready to go. Because it takes 5 seconds before it like kicks in.
Oh, wait, do it. Wait, hey, don't play it.
Go ahead and get it queued up. Okay?
I am ready.
Now, I need 9 other people right now. 1, 2, 3, 4, 5, 6, 7, 8. Did I give you 9? Okay. So I'm going to play it. I'm going to one source. 1,000, not 10,000. 1,000. Yep, there you go. Okay. Yeah. Okay, don't be done. I need your phone. All right. We're going to do this. We're going to do 2 different experiments. Okay. Here's one source. Okay, everybody play, sorry, the people I called, play it. Okay, there's 10 sources. We would say, well, that's twice as loud, but it's 10 times. Okay, everybody hit pause. Okay, now, and everybody participate in this one. We're going to go 2 sources, and then we're going to go 20. There's 19 of cell phones that were a little shy, but okay, so make sure everybody gets us on this. Everybody who's not paying attention, playing chess, stop playing chess. And what did I call that?
Wait, so is intensity and perceived sound the same thing?
Number of sources. Is that what you perceive?
volume,
No.
what does that mean?
Just like, oh, that's twice as loud. I know.
This question though. I like get it. I get it this, but like how it works with the math, I don't get that.
Yes, I understand.
I'm listening to Taylor.
Okay.
Yeah.
Does everybody have 1,000 hertz?
Yes.
Okay. Ready. Caitlin and I are going to play it. Ready? Here's 2. Okay. Now, everybody play it. Theoretically, if everybody played it, that's twice as loud. Okay. Pause. Okay. If everybody, okay, now this comes with some sources of air. 1, all phones aren't the same. Maximum volume is different. 2, we're not all at the same location. You're hearing it from different but did that, it wasn't like 10 times the volume you would expect. It's not a linear scale.
I found a video that says music to kill cancer cells. Can I play it? Yes.
It's not gonna work.
Wait.
This isn't it. It's an act.
Intensity.
All right, that's good. Say what?
Intensity is the same as the number.
Yeah, that's sources. Number of sources and intensity goes hand in hand. Okay? All right. Here we go.
And then so awkward. I'm sorry.
She was looking around too. She's like, turn it off.
I didn't think it was playing because I couldn't hear anything. And then everyone was looking.
Like, what got me? She's looking around the tides. Turn it off.
Lexi, I'm gonna miss you next year.
That's so sarcastic.
No.
I just have
Did you
hearing
call me
problems.
like 30 degrees?
Oh.
Did not know. So you just forgot about me. She knows it's going on.
Hey, I've been paying attention today.
They'd do so much better if they would just pay attention. It's crazy.
Have you noticed? I've been really quiet.
You have.
From that little bit.
All right. Here's a question up on the board. And tell your neighbor. Correct answer is A. Have the number of sources. If we have the perceived volume, like, oh, that got half as loud, it has 1/10 of the number of sources, 1/10 of the intensity. Good with that? Okay, now, this type of conversation, what we're having, screams logarithms. Okay? Now, when I was in your shoes, I could get A's on this test, on logarithms test. Like I had that on lockdown. I was like, sweet. The B gets bigger, the X gets smaller, and the Y flips over the other side. Had that. Boom. I had no idea what I was doing though. I could get A's on the test because I could repeat the pattern, but I had no comprehension. Okay? My hope today is that you leave here with a greater comprehension. If you could relate to my experience, my hope is to show us why in the world we do this crazy math stuff. Okay? Is to address this issue of what the conflict that we were just having, like mathematically that doesn't make sense. Like why So we employ logs to help us with that. Okay. So, and just quick disclaimer, in this class, I'm going to always use base 10, log base 10. Okay. Okay, if I have 100, that is equal to 10 to the what power? Just try. Okay, to the second power. So if you have log of 100, you plug that into your calculator, you're going to get 2. Because what a log focuses on is 10 to the what power? It focuses on the exponent. It focuses on what exponent do we raise 10 to? If you've heard of exponential, exponent, exponential, that's like, there's a connection there. Okay? It says what? Yeah. So if I say log of 10 million, that's going to be what? 1, 2, 3, 4, 5, 6, 7. That's going to give you 7. 7. Okay. 10 to the 7th power gives you 10 million. So the focus is, when we do logarithms, it focuses on the exponent. Good with that? Now, I've given you really simple examples that you can just like count the zeros and get the right answer. Okay? Now, what would happen if I said, what's the log of 5,000? Don't do it on your calculator. Don't do it on your calculator. You have to do it on your calculator to get the right answer. But what I want you to do is estimate. Or better yet, what is the range? The answer is going to be between this and this. Tell your neighbor and tell them why you came up with the answer you came up with. Okay, I heard a lot of good answers. 5,000 is somewhere between 1,000 and 10,000. So the log of 1,000 is 3. The log of 10,000 is 4. So this is going to be 3 point something. Does that make sense? Okay. When you plug, okay, to get the whatever that is, you need a calculator. Prior to calculator, they had a book, catalog. You'd have to look up. Okay. The answer is not 3.5. It's not, because it's halfway. It's 3, I think it's 3.7. Okay. You need a calculator. Logarithmic scales are not linear. They're exponential. Okay. Our brain doesn't think that way really, unless you had a lot of practice with it. Okay. Good with that? Now, applying these, the Richter scale, like for earthquakes, is logarithmic. So let's say we had an earthquake of 4 on the Richter scale. And then we had a second one that was 5 on the Richter scale. And you're like, yeah, that's just one more number. What that is, folks, that is 10 times the intensity because the Richter scale focuses on the exponent. It's logarithmic. If you had an earthquake that has 6 on the Richter scale, that is 100 times the intensity as 4. That's huge. Okay? So every time you increase a number on a logarithmic scale, that is like a substantial increase. Like 10 times that. Okay? So, logarithm or decibels, how we perceive loudness fits right into this. Okay? So, we got 4 blaring car horns produce a total sound of 70 decibels. What is the intensity of the sound? So, I'm going to use this equation. I've got 70 decibels equals 10 log. I'm looking for that intensity. And then the threshold of hearing. Okay? That's the quiet. This is the quietest that we can hear. It's a constant. I'll give it to you. Okay? Now, divide by 7. Sorry, divide by 10. Now, this next thing is not imperative. This is just giving you if you're more math inclined, this might help make this make sense. So we have kilometers, then like meters, centimeters, millimeters, metric system. Okay. In between meters and centimeters, you have decimeters. Good with that? 7, this is the number of bells. Like as in Alexander Graham Bell. Okay? For whatever reason, as a scientific society, we've landed on we don't want bells, we want decibels. Okay? This, you don't have to convert anything. This is what's actually exponential, the bells. This equation is prepackaged with the conversion. That's what this 10 does. Okay? If none of that made sense to you, don't worry about it. Just plug the numbers in the equation and you'll be fine. Okay? So, we're do inverse log to get rid of the log. So now we have 10 to the 7th. Get 1 times 10 to the negative 12th over here. So you have 1 times 10 to the 7th multiplied by 1 times 10 to the negative 12th. And you get 1 times 10 to the negative 5th watts per meter squared. Plug it in the equation. We're going to use that on the next slide. So, 4 cars produce a sound of 70 decibels and an intensity of 1 times 10 to the -5th. What would be the intensity of 1 car horn? And this is the intensity of 4 car horns. What would be the intensity of just 1 car horn? Tell your neighbor. How would you figure that out? Okay. Intensity, we like that mathematically. Like, this is 4 car horns, so 1 of them, you just divide this by 4. Okay, intensity makes sense. It adds up. It's like, so we just divide this by 4, and we get, I know this is incorrect scientific notation, but just roll with it. So it'll be a fourth of that. You okay with that? Okay. Now, I want to know how many decibels that is. Just 1 car horn. Okay. Before we calculate it, I just want you to estimate. We know that 4 car horns is 70 decibels. How many decibels would 1 car horn be? Just from the hip. I think. Okay. You have a hypothesis. Knee jerk reaction from the hip. Okay. Does everybody see where we're going here? So I've got my intensity. I want to know how many decibels it is. So I'm going to plug that into this equation. Plug it into the equation. So I say log of 2.5 times 10 to the 6th equals 6.4. 6.4 is how many bells there are. Times 10, this gives us how many decibels there are. 1 car horn, 70 decibels. Sorry, no, 4 car horns, 70 decibels. 1 car horn, 64. What? It's my whole point is it's not linear. You're not going to be able to estimate that. You're gonna need a calculator. I did. I know. I wanted to show you that your estimation is going to be all whacked out.
What is that?
That's the decibels of 1 car horn.
But I thought decibels were spelled with 1 L, so did they spell it wrong?
Wait, what are
Was this
decibels?
bell 2 letters?
Oh.
What are decibels?
Yeah,
They
maybe.
must have
What
spelled
is
it wrong.
Yeah.
That's embarrassing.
Is
What?
that like volumes? That's what that is?
Perce-
Decibels,
yeah.
When you listen to something, and your
One
AirPods tell you it's
Is
too loud.
64 and 4 is 70?
Yep. Not linear.
But that,
You're right.
See, it's a lie.
I feel like
No, it's
3
actually.
should be 64. 3 cars
Yeah,
should be
that
64.
would seem right.
That would make sense to me.
Not linear.
I don't like that.
I know. That's why you use the equation. Okay. Before I erase all this, any questions? Those who care. Sure.
It's half raised, but okay, I got it.
Okay. Okay. One car horn was 64.
I know it's not 64 times 2. 64 times 10. Yeah? Yes.
Have a conversation.
I am so confident. Yeah. Oh, she shot it. I was. Wait, it's 1 is 64 and 4 is 70. Then how is 2 more than 70? Wait, no.
No. This is
The intensity?
this is if you double the volume, double the perceived.
Wait.
You're like, oh, that's twice as loud.
No, but the thing that we plugged into that was intensity. It wasn't volume.
Right.
Yeah, but we got the volume out. Oh no, that's the intensity. What? That's the volume of 1. The volume of 2.
Okay. This is drawing from what you might have written down from the pre-quiz. Correct answer is A.
What?
Okay. Here's the factoid. If you double the perceived volume, like, whoa, that's twice as loud, you're adding 10 to decibels. You're adding 10 to decibels. You're multiplying by 10 for intensity and number of sources. Okay? If you're like, whoa, that's twice as loud, that's plus 10 decibels. That's times 10 for intensity. Okay? Check this out. We said that four of these, one of those was 64. 4 of them were 70. Does it make sense that another 6 is going to be 74? So it's 10 times the number of sources, 10 times the intensity, plus 10 for decibels. Jiffy.
There's 10 cars then, 74 decibels.
Yep. There would be 10 cars.
What? There's 10 cars?
To make 74 decibels. Because there's 10 times the number of sources, 10 times the intensity. Okay, try this one.
Yeah.
Do what?
He's not rapping.
I know.
How's 10 cars 74, 1 car 7, or 2 cars 70, and 1 car 60?
I know, it's not linear.
Really, we get it. Not linear. It doesn't mean anything to me.
Okay. Let me get through this, and then I'll hit the bells. But if you're struggling, like, I don't understand how this corresponds with my understanding of math and logarithms, I will make that make sense. But for right now, I just want to get the general, and then we'll.
Wait, aren't logarithms, don't they like start big and then they get smaller? Okay, so that's why it gets.
Okay, here we go.
Give me a second.
Good question. If it says doubled the volume, it's perceived. If it's like asking for straight up decibels, then no. Thumbs up when you have a guess. Have a conversation. Correct answer is dangerous dinosaurs. Okay. Good with that. You're multiplying 10 by the number of sources, and you're adding 10 to your decibels. Okay. Next question. Tell your neighbor.
I'm just gonna sit them in front of the TV because I think she literally said, huh?
Okay, what do you say?
No.
Correct answer is crazy cats. Here's the idea. If we go from 95 to 85, we subtracted 10 from decibels, we divide by 10 for the intensity. Everybody go with that? When we go from 85 to 75, we divide by 10 yet again. So that's 100th of that. Good with that? Okay. Now, here's a chart kind of relating these. For those who are like, I want connections with life, or not math, sorry, with not life, but math. This is the number of bells. This is the exponential, this is actually the exponential equation, or the exponential scale. Decibels makes it a little convoluted, okay? So 1 times 10 negative 12th, that is our threshold of hearing. This is the quietest we can hear, 1,000 hertz, okay? That's baseline, okay? 20 decibels is a whisper 1 meter away. That's kind of a relative scale because I've heard some people whisper, "Hey, did you hear what he said?" No, but the whole class is about to. Normal conversations, 60 decibels. A loud radio or a classroom, I guess I'm loud. 80 decibels. Siren 30 feet away is 100 decibels. You're causing damage if it's more than 30 minutes. Okay. If you ever walked out of a concert and your ears are ringing, that's your eardrums being thrashed back and forth too hard for too long, and you cause that ringing is damage, like it's indicating that you're damaging your ear. Okay. It's like, ah, you just killed me. Okay. That your ear will heal partially. Every time you cause hearing damage, there's some of that that's permanent. Ooh. The more and more you experience that, the more and more as an elderly person, you're like, huh? Can you speak a little louder? Sorry, I listened to my music too loud when I was in high school. I can't hear you. Like if you want a good occupation where you know there's going to be a lot of patients, audiology, like being an ear doctor, like can't hear anything, hearing aids type stuff. Okay, let's go with that. So this chart here is a chart of volume, how loud it is compared to the frequency. So this is like low frequency, high frequency, and like quiet, loud. Okay, and how that works out. Okay, this last, yeah, when it hurts. This last slide, this was revelatory to me. Hearing damage is not only a function of volume, too loud causes hearing, but also is a function of time, how long you're exposed to that sound. Okay, we all know that loud sounds are bad, but like mowing the lawnmower isn't that loud. But if you're exposed to that for a long period of time, that is damaging. Does that make sense? It's not just a volume thing, it's a volume and how long it is. So the longer you're exposed to something, so let's say you're working in a factory that has a like 100 decibels, it's like you got something. If you're in there for a whole 8 hours, that's going to cause hearing loss. You do that every day, you're deaf by 50. Okay? Does that make sense? Okay? All right. For those who are like this, so that helps. Oh, no, it doesn't. Oh, yes, it does. Noise cancellation has one. Yes, it helps.
Oh yeah. My grandpa's always wearing those when he's mowing
Yeah, it helps. All right, so, JP. It's just so fast. It doesn't actually. If it was that loud for like longer period of time, you would rupture your eardrum.
So you're telling me like one shot or like 2 or 3 shots is fine, but like.
I mean, are you trying to bust your eardrum? you're caught. Like you, every time you ring, so like when you shoot the gun, your ears ring. That's hearing damage. You will recover mostly.
So one shot is still damaging.
Yes. Okay. You're out. You got a worksheet due tomorrow. What? Mhm. See ya.